Hello YouTube. I am going to attempt to explain a physics problem for you. You might ask what makes me qualified to explain physics to anyone, and the answer is I'm not. So here goes. If we are given the coefficient of kinetic friction, which we are, we want to find out what the force is that will be required to push this 65 kilogram crate up a 25-degree angle at constant velocity. And I've underlined constant velocity a couple times because that's pretty important, because we know that if something is at constant velocity, then the summation of all the forces, or F net, is going to equal to zero vector. So basically they all cancel each other out. We're going to ask ourselves what forces are acting on the crate. There's gravity, which is a long-range force, and the rest of the forces are actually touching this crate. Gravity doesn't have to touch it, but it's affecting it still. So the forces that are touching this crate are the surface pushing back up against the box. That's going to be our normal force, and it's going perpendicular to the surface. We have friction, which is going against the direction that the box is being pushed, but perpendicular to the surface. And then we have the force that this guy is actually pushing that crate that way. And that's can be explained by, our F of P there. So what we want to do is draw a force diagram so we can visualize all of these forces acting on this one object. If we were to draw it exactly how this was viewed right here, we would basically end up with this, which is correct, and the problem could be worked that way, but I suck at math, and all of these angles add a lot of math. So you can redraw this. This equals this exactly, because the coordinate system is just a tool for you to use. So we're going to redraw it to where basically we're going to eliminate a lot of components. Our friction now has negative x components, but no y components. Our force of pushing has positive x components, but no y components. Our normal force has positive y components, but no x components. And the only thing left is gravity here, which the way we redrew it is actually pulling at an angle, or it appears to be here. So we're going to have an x component, which is going to be represented by basically the magnitude of this, our hypotenuse times sine theta. And then we have our y component here, which is going to be interpreted as our magnitude multiplied by cosine of our angle theta there. And theta, of course, is 25 degrees because we know that from there. But it's a lot easier if we don't plug in all these numbers right now. And it becomes a useful tool at the end also. I can explain that. As I stated previously, let me back up 1 second. All of these forces are vectors, which means they have a magnitude and a direction. So we're going to break those down into scalars, which is basically the XY components of it. So that's going to make it possible for us to add all these forces together. All right, so as I stated, since the crate's moving at constant velocity, we know that F net equals 0. So all of the x components, friction, x, the pushing x, and the x component of gravity are going to equal 0x. We can rewrite that mg x hat equals negative fk x hat minus fp x hat. And to solve for the mg x hat, we have to use some trig functions there. Like I said before, mg sine theta basically is going to give us our mg x hat. So we can rewrite it, mg sine theta equals negative force of friction minus the force of pulling, the x components of those. And since the force of friction can be modeled as mu the subscript K in for kinetic friction, we can also say that mg sine theta equals negative mu k in x hat minus fp x hat. And rewrite it in terms of fp x hat because that's what we're trying to solve for. And we could say fp x hat equals negative mg sine theta minus uk in. Basically, we want to do the same thing on our y components. So you isolate them. We're trying to rewrite this in terms of in right now, basically. That way we'll be able to plug it into this other formula and solve for f. So if you rewrite the fact that ny hat plus mgy hat equals 0 y hat, you ultimately end up with ny hat equals negative mg cosine theta, because the mg y hat is equivalent to mg cosine theta. So you plug that into the formula that we ended up here, and you're left with fpx equals negative mg sine theta minus uk mg cosine theta. And once you plug in all the numerical values, you find out that it takes a force of 442.4 newtons to push the crate up the 25-degree incline at constant velocity. Now, as I mentioned, the reason you didn't want to plug in your numbers before is you're left with this. So basically, now you can change any of the variables in here. You can change the weight and get a different outcome, see how much force it would require. You could change the angle and see how much force it would require to push it. So that's basically it, my unqualified lesson in physics.